Hi everyone. In this video I want to explain you a complete data pipeline architecture on AWS designed for an e-commerce platform. So this pipeline captures user events in real time, processes them, and then prepares them for advanced analytics, applying best practices. And yeah, as you can see, this pipeline consists of several AWS services working together to create a robust data flow. And I want to explain each component in details, its configuration, and the best practices that make it effective. So, about capturing events from e-commerce, I'm using Amazon Kinesis. So, the process begins on the e-commerce site. Each time a user performs an action like viewing a product, adding it to their cart, or making a purchase, an event is generated. So these events are sent to Amazon Kinesis data streams, which capture large volumes of data in real time and stores it in a data stream for processing. And to ensure that Kinesis handles events effectively, we monitor the message backlog to prevent accumulation, and we configure encryption to protect data in transit within the Kinesis team. About the real-time processing with AWS Lambda, each time an event arrives in Kinesis, it triggers an AWS Lambda function that allows us to run code without managing servers. That is ideal for real-time processing. So the Lambda functions validates and cleans the data from each event and then saves it to Amazon RDS for structured storage. So in this case, we are using PostgreSQL in RDS. So in this part, it's a recommendation to use different key practices like automatic retries in case of transient errors. So another is encryption in transit to protect data when sending it to RDS, and using secure environment variables to store credential and configuration in Lambda. And what else? The data store in Amazon RDS, about the data storage. Amazon RDS acts as the structured data store where processed events are stored. This allows for quick queries on recent data and facilitates integration with other systems. And to ensure availability and security, we enable multi-AC replication for fault tolerance, and we configure automatic backups. We restrict access to the database using security groups and IAM roles. About transferring data to Amazon S3 in Parquets or Avro format. For long-term storage and batch processing, data from RDS is periodically exported to Amazon S3 in Parquet or Avro format, because these formats are ideal for large data volumes and batch processing. And we're applying best practice in this industry, like configure lifecycle policies to delete all files and control costs. And we ensure that data in S3 is encrypted, the rest using SSE S3 or SSE KMS. About the ETL with AWS Glue, to transform and prepare data for analysis, we are using Glue that loads the data from S3, applies the necessary transformation, and then loads into Amazon Redshift for advanced analytics. And with AWS Glue, also organize data in a data catalog, making it accessible to other services. In AWS Glue, we configure a data catalog to manage data centrally. We adjust processing capacity using data processing units, DPU, to optimize cost and performance. And now the storage and analytics in Amazon Redshift. The transformed data is stored in Amazon Redshift. We can use advanced queries that can be run to gain insights into users' behavior. Redshift optimized for complex query or on large volumes of data. To optimize this performance, we use data compression and partitioning in Redshift to speed up queries. Also, we configure the cluster to auto-escalate based on workloads and optimizing costs. And also, we protect sensitive data by implementing access control with IAM roles. And with Amazon QuickSight, about the visualization in this tool, we connect Redshift with QuickSight to provide interactive visualization and reports. So we can create dashboards and view key metrics like conversion rates, popular products, and behavioral trends. In QuickSight, like best practices, we set up security roles and permissions to protect the data. We optimize query usage by setting up a schedule cache refresh to reduce query costs in Redshift. And about the orchestration with AWS step functions, as you can see in the diagram, to coordinate each stage of the pipeline, we use this tool, step functions, because it allows us to create sequential workflows and handle errors, retries, and conditional steps. Also, this tool controls each task in the pipeline. It triggers the Lambda to process the events. It initiates the job to transfer data from RDS to S3, and it launches the Glue job to transform data and load it in Redshift. And also it configures retries and error handling at each step to ensuring pipeline continuity. And about monitoring and use alerts with Amazon CloudWatch. With these tools, we can monitor each component in the pipeline from Kinesis to Redshift. CloudWatch metrics allow us to see performance and receive alerts if there is any issue. In CloudWatch, we are using best practices like set up alarms on the Kinesis backlog to prevent accumulation. Also monitor the CPU and memory usage in Lambda to ensure optimized performance, and we establish query metrics in Redshift and send alerts of query costs that exceed other scope. So in this pipeline, and in this data pipeline on AWS, it provides a complete solution for capturing, processing, and analyzing data in real time, applying best practices. For example, security, efficiency, and scalability. So thank you so much for watching this video. I hope this explanation helped to understand how to implement the data pipeline on AWS. Thank you.